Scientific method is a process or sequence of activities undertaken to gather information and to come to conclusion about the natural world. According to Maria Ryan and Angela O'Callaghan in 2002, there are 5 steps in conducting scientific method.
Very first step in doing a scientific method is to make an observation. Through observation, we can gather the similate information about an event, phenomenon, process, or an exemption to a previous observation. In this scenario, we can see that there is no water. In order to start our investigation, we must observe. We can gather information through reading, watching news, or by simply having conversations with others so we can see the problem. We gather basic information and take down notes so we can identify the problem.
The next step of the scientific method is to define the problem. We ask questions about the observation that are relevant and testable. Here, we define the null hypothesis to provide unbiased results. Water is necessity that every human, animal, and plant needs. It is essential for life forms to do their purpose and create life. The scarcity in water greatly affects us all. With the observation and information we gathered, it is clear that it all points to a certain dilemma. There is a scarcity in water and we want to know what causes the scarcity in water. To find out the solution to this problem, we must make a hypothesis where we can test our theories.
The third step of the scientific method is forming the hypothesis. In this step, we create an explanation or educated guess for observation that is testable and falsifiable. The scarcity of water as a problem in general. So we need to come up with a main problem where we can focus and solve it one at a time. For example, in our given scenario, there is a scarcity in water and little rain. This may be because of the hydrological cycle. So could it be that the water that is in the ground is not moving at all to be able to get back on bodies of water through aquifers? So to test this, we must make the first hypothesis, which is the scarcity of water is influenced by the porosity and permeability of soil types in the aquifers. So if the soil type is more porous and permeable, then water flows easily. So it means there's no scarcity in water. And if the soil type is not porous and permeable, then water flows barely or not at all. Then there will be no water because the hydrologic cycle is disturbed. So we will stick with this theory until we can prove it false or not after the experimentation and the conclusion.
The next step is to conduct the experiment. We will devise and perform the experiment to test the hypothesis. In this experiment, we will need 3 types of soil, containers, and water. We are going to measure how fast water flows in each type of soil to find out if the flow of groundwater is affected by the composition of soil, which therefore results in scarcity of water. The 3 types of soil in this experiment are sandy soil, clay soil, and loam soil. Prepare the plastic cups with holes at the bottom, then fill each cup with different types of soil. Add another cup at the bottom to serve as a catch basin for the water. 125 ml of water is poured in each type of soil and the timer is set. The results show that the water flowed through the sandy soil in 1 minute and 11 seconds. The water flowed through the clay soil in 1 minute and 15 seconds. The water flowed through the loam soil in 1 minute and 17 seconds. Results show that out of 125 ml of water, only 60 ml of water flowed through sandy soil, 40 ml on the clay soil, and 120 ml on the loam soil.
After making an observation, defining the problem, forming of the hypothesis, and the highly important conducting of the experiment, the final part comes next, which is to draw conclusions. In this final step, We use the data and measurements collected from the experiment for the analysis and interpretation of it, and to finally formulate conclusions. If we go back to what Jenna said in step 4, variations in the results measured are evident. In terms of the speed that the poured water took to completely reach the catch basin, sandy soil took the shortest time, making it the most permeable one, as permeability is the measurement of how well does the soil type allows the flow of water to pass through it. While in terms of the amount of water in milliliters that reached the catch basin, it was revealed that clay soil had the most amount of water that passed through the soil type and made it to the catch basin, making it the most porous soil type, as porosity is the measurement of how small the particles are and how the voids between the particles are. If we integrate these concepts, we can conclude that less porosity and more permeability leads to less water that passes through the soil type, and more porosity and less permeability permits more water that passes through the soil type. And to answer the hypothesis of this problem, the answer is yes. Scarcity of water is influenced by the porosity and permeability of the soil type in the aquifers. So, the ideal characterization of the soil type is more porosity and less permeability, so that more water can flow back to the bodies of water and further help in the hydrologic cycle. After everything we've discussed, now comes the finale. As we are greatly involved in the scientific field, obeying to the scientific method is important. As we all know, scientific method is the standardized approach, as it is the systematic way of finding answers and solutions to unanswered and unresolved things. In this way, bias is minimized because of its systematic scheme of doing such work. Without bias in the results obtained after the whole process can be used in a widespread and meaningful manner.